Hi guys, welcome back to Math with OG. Still on number basis, we'll be looking at addition and subtraction in order basis. There are two ways you can go about it. One of the ways, which is actually a longer method, and we won't be looking at that, is by converting this to base 10, converting this to base 10, do the addition, then convert back to base 2. However, the simplest method is solving in a particular base. So I'll be making reference to base 10 to make us understand it better. Now let's start with 10111 base 2 plus 111 base 2. Just like your base 10, you arrange by putting them in such a way that the numbers with the same value by that I mean unit term should be with unit term, tens should be with tens. So the same way you do that in base 10, you also do that in base 2. What do I mean? If this is 425 and you have to add up with 16, this is unit, this is tens, this is unit, this is tens, and this is 100. So if you are to add up, you add up units to units, you add up tens to tens, and you add up hundreds to 100, and the 100th term here is 0. That's why you arrange this way: unit plus unit, tens plus tens, then you have 100. And you also observe that the moment you are adding, when you get to 9, the next number will be 10, which is base 10, and for that 10 you now have to carry 1 to add to this 10th term. So we are going to use that same approach in solving this in base 2. So pay attention, and if you don't understand, you can simply pause the video or rewind back and go over it for the second time. So this is 10111 base 2, and what I have here is 111 in base 2. Now let's add together. 1 plus 1 is simply 10 in base 2, or you can say 1 plus 1 is 2 in base 10. Now what is 2 in base 10? 2 in base 10 is simply 10. Since 2 in base 10 is 10, you are going to put down 0 and carry 1. Now we can go again. 1 plus 1 is 2. 2 plus 1 is 3. 3 in base 10, but we are working in base 2. Now what is 3 in base 10? 3 in base 10 is 1. So we are going to put that 1 and carry 1. We go again. 1 plus 1 is 2. 2 plus 1 is 3. What is 3 in base 2? 1. So we'll put down 1 and carry 1. 1 plus 0 is 1, and 1 is 1 in base 2. Then you drop this 1. So this should be your answer: 11110. So your assignment is for you to convert to base 10, solve, and cross-check if we are having exactly the same answer. So this is the answer to the first question. Second question, we have 10001 and we have 111. In this case, we are subtracting. 1 minus 1 is 0, so we'll put 0. Now let's go to base 10. For example, you are given this question: 4502 minus 81. Say 2 times 1, 2 minus 1 is 1. Then say 0 minus 8. It can't go through. So we borrow 1 from here. We are not actually borrowing 1 from here, we are borrowing 10 from here. So you collect a number, and that number is equal to the base. So if I borrow 10 from here, what will come here is simply 10. Then we'll now do 10 minus 8, which is equal to what? 2. So if you have a question like this, 4572, you have 889. You say 2 minus 9 cannot go through. What we borrow from here is actually 10. What we borrow from here is actually 10. So we'll put that 10 here. 10 plus 2 will be 12. 12 minus 9 will be 3. So because I borrowed 1 from here, I'm left with 6. So 6 minus 8 cannot go through. We also borrow 1 from here, but that one is actually 10. So we have 10 plus 6, which is 16. Then 16 minus 8 is 8. Here I'm left with 4. Borrow 1 from here, which is 10. 10 plus 4 is 14. 14 minus 8 is 6. And lastly, here is 3, and it will drop here as 3. So the same thing will happen here. Since in that case I was borrowing 10, working in base 10. In this case, I'll borrow 2 working in base 2. Now I'll start borrowing from here. I'll borrow 2, so here will be 2. Now borrow 1 from this 2, here becomes 1. So here will be 2. Borrow 1 from here becomes 1. So here will be 2. Now 2 plus 0 is 2. 2 minus 1 is 1. And 1 is 1 in base 2. 1 minus 1 is 0. 0 is 0 in base 2. 1 minus 0 here is 1. Remember I borrowed 1 from here. So here is automatically becomes, or here automatically becomes 0. So this should be 0. And there's no need to put a 0 here. It is insignificant. So draw this, and this is our final answer. Over to the next question. Next question, we have 9a8 minus 4b9, both in base 16. Now 8 minus 9 cannot go through. So what do? I borrow 1 from here. Okay, now we are working in 16. What do we call it? We borrow 16. So this automatically becomes 16 plus 8 minus 9. So let's solve together. 16 plus 8 is 24. 24 minus 9 is 15. Let's confirm 24, 9, 14. Okay, this is 5. So it is actually 15. And what is 15 in base 16? Let's bring out these values: 10, 11, 12, 13, 14, 15. So this is A, B, C, D, E, and F. 15 is F, so here automatically becomes F. Now this was A before, and A is actually 10. I borrowed 1 from here, so here should be 9. So this is 9. 9 minus B cannot go through because B is 11. So we'll borrow 1 from 9, and that's 1. Rather, we borrow 16. I'm used to 1 because of base 10. We'll borrow 16. So this will be 16. 16 plus 9 is 25. 16 plus 9 is 25. Now 25 minus B, that's 25 minus 11. 25 minus 11, this will give us 4, and this will give us 1. 14. 14 in base 16 is E. So here automatically it's become E. Now remember I borrowed 1 from here. So here I should be left with 8. 8 minus 4 is 4, and 4 is 4 in base 16. So the answer is 4EF base 16. Now next is 1A35 in 16 minus F7E. I can put that here. 1A35 F7E. We are asked to subtract, so you can see how easy it is. Now let's bring out our ABCD again. A, B, C, D, E, F. 10, 11, 12, 13, 14, 15. 5 minus E, obviously it cannot go. Borrow 1 from here, which will come here as 16. So 16 plus 5 is 21. 21 minus 14. 21 minus 14 is 7. So I'm left with 2 here. Now 2 minus 7 obviously cannot still go through. Borrow 1 from here. That one will come here as 16. 16 plus 2 is 18. 18 minus 7 should give us 11. And 11 in base 16 is B. So this should be B. This was formerly A. Borrowed 1 from there. So that place should now be 9. 9 minus F obviously cannot go through. Borrow 1 from here. Come here as 16. 16 plus 9, 25. 25 minus F. F is 15. 25 minus 15 is 10. And 10 in base 16 is equal to A. So this should, or this will be A. So my final answer will be AB7 base 16. Now next question, we have 432 plus 104 in base 5. 432, 104 in base 5. 4 plus 2 is 6, and there's no 6 in base 5. So what is 6 in base 5? 6 in base 5 is 1, 1. 5 in base 5 is 1, 0. So 6 in base 5 is 1, 1. So you can check by yourself. 5, this is 1, remainder 1. 5, 0, remainder 1. So it is 1, 1. So we are working in base 5. So this should be 1. Put down 1, carry 1. 1 plus 3 is 4, and 4 is 4 in base 5. 4 plus 1 is 5. There's no 5 in base 5. And 5 in base 5 is 1, 0. So we have 1, 0, 4, 1 in base 5. Next question, 100.01 minus 11.101. 100.01 minus 11.101. Everything in base 2. Now, let's subtract. 0 minus 1 cannot go through. Borrow 1 from here to come here as 2 because we're working in base 2. 2 minus 1 is 1. We borrowed 1 from here, so yes, automatically 0. 0 minus 0 is 0. 0 minus 1 cannot go through. We cannot borrow from here. We can't borrow from here, so we'll start from here. Borrow 1 from here. This will be 2. Borrow 1 from here. Here automatically turns to 1. Here should be 2. Borrow 1 from here. Here automatically turns to 1. And here will be 2. 2 minus 1 is 1. Point. Now here is 1. 1 minus 1, 0. 1 minus 1, 0. Remember, we borrowed 1 from here. We borrowed 1 from here. So here is automatically 0. So this is 0. So we can't write 000.101. Doesn't make sense mathematically. So I can clean this 2. So my answer is 0.101 in base 2. 0.101 in base 2. Now the last question. The reason for the last question is just to explain that whenever you are asked to add or subtract in two different bases, there's nothing that can be done. There's no magic that you can perform and start saying 2 minus 1, putting some things together that does not actually make sense. So what you should do is either you convert this to base 3, you subtract, or convert this to base 2, subtract, or convert both guys to base 10, subtract, and leave your answer in the base that you were asked to leave your answer. So let's assume that the question was 212 base 3 minus 111 base 2. Leave your answer, leave answer in base 4. Since we have to leave our answer in base 4, convert to base 10, convert to base 10, and subtract. So let's do that together. So we have 212 base 3, 212 base 3. To base 10, we are going to have 0, 1, 2. So this is 2 times 3 raised to the power of 2, plus 1 times 3 raised to the power of 1, plus 2 times 3 raised to the power of 0. 3 raised to the power of 2 is 9. 9 times 2 is 18, plus 3 raised to the power of 1 is 3. 3 times 1 remains 3. Then 3 raised to the power of 0 is 1. 1 times 2 is 2. 18 plus 3, 21. 21 plus 2 is 23. So this is 23 in base 10. Now move on to 111. 111 base 2, this is 0, 1, 2. 1 times 2 raised to the power of 2, plus 1 times 2 raised to the power of 1, plus 1 times 2 raised to the power of 0. This is 4, this is 2, and this is 1. So the answer is 7. So we have 23 in base 10 minus 7 in base 10. So what is 23 minus 7? Obviously, the answer is 16. 16 plus 7, okay, yes. So that's 16. Now let's convert 16 to base 4. So let's use this small space here. Let's use this small space here. 16 to base 4. 4 into 16 is 4 remainder 0. 4 into 4, 1 remainder 0. And 4 into 1, 0 remainder 1. Reach from bottom to top. So therefore, this minus this is equal to 100 in base 4. If you have to leave your answer in base 2, convert to base 2. As to leave your answer in base 3, convert to base 3. So as you can see, it's actually very easy to add and subtract in other bases. So this is where we'll be drawing the curtain on addition and subtraction in other bases. Now next video, we'll move on to multiplication and division in other bases. Thanks for watching this amazing video. Please hit the like button, leave your comments in case of any observation that was wrong or any other comments you wish to leave. Then also subscribe and share to your friends. See you guys in my next video.